A very warm and happy morning to you all children. Last week we started with the lesson work, energy and power, and in that we have completed the subtopic called work. So to recall work, what is work done? Work is said to be done when a force acts on a body and it moves to some distance. And how do we calculate the work done? Work done is calculated by the formula force multiplied by the distance. And the SI unit of work done, we have seen it as joule. So how can we define a joule? The SI unit of work done is Newton meter, but we are expressing it as a joule. 1 joule is the amount of work done on an object when a force of 1 Newton displaces it by 1 meter along the line of action of the force. And also we have seen work done can be positive, can be negative, and it can even be zero. So these are the various subtopics we have seen in work done. Now let us take up the next subtopic, energy. You might have heard this word and you have used this word energy in your daily life. In other words, if you want to do work, you need energy. So energy can be defined as the ability to do work. And in this energy, there are various types of energy, and among the various types of energy, we are particularly going to deal with mechanical energy. This mechanical energy is a combination of potential energy as well as kinetic energy. So we are going to see elaborately about this topic, energy, today. Come children, we'll go into the lessons. Children, we will right now take up the subtopic energy. It is the ability to do work. That means energy is the ability to do work. It is always essential for performing any mechanical work. An object having the capacity to do work is said to possess energy. The object which does the work loses energy, and the object on which work is done gains energy. The energy of an object is measured in terms of capacity of doing work. The SI unit of energy is same as that of work, that is joule, J. 1 joule of energy is required to do 1 joule of work. A larger unit of energy is kilojoules, where 1 kilojoule is equal to 10 to the power 3, that is 1000 joules. Work done against a force is therefore stored as energy. Example, when a fast moving cricket ball hits a stationary wicket, the wicket is thrown away. So the work is done by the ball. So the SI unit of work done is joule. So in short, energy is the ability to do work. Now, when energy can be classified as many types, as mechanical energy, electrical energy, sound energy, so on and so forth. In this, we are going to focus only on mechanical energy. This mechanical energy is of two types. One is potential energy and the other one is kinetic energy. So energy that can be used to do work is known as mechanical energy. It is the sum of an object's kinetic and potential energy. We are going to learn in detail for this potential and kinetic energy in the upcoming slides. Examples: elevator, car, hammer in motion. So all these examples reveal the position of the mechanical energy, which is the sum of potential as well as kinetic energy. Now let us take up potential energy. The first paragraph gives you the definition of potential energy. The potential energy of an object is the energy possessed by the object due to its position or shape. This position or shape is very important. So depending upon the position of the object or the shape of an object, we will reveal whether it has potential energy or not. So the potential energy of an object is the energy possessed by the object due to its position. Now you may not be understanding this concept. After learning some examples, I hope you will come to the understanding of potential energy. Now let us take up the first example. If a rubber band is stretched and then released, it regains its original position. When the rubber band is stretched, the energy is transferred to it and stored as potential energy. So in this example, a stretched rubber band is an example of potential energy. A normal rubber band, when you stretch it, elongates or increases in length. So the stretched rubber band on your hand possesses the potential energy. On the other hand, when you leave the force on your fingers, it regains its original shape. So as long as the rubber band is stretched, it is having potential energy. Now you may understand the word due to its position. So here the position is stretched. Now let us go to the next one. If we wind the key of a toy car and place it on the ground, it moves. When we wind the key of the car, energy is transferred to the spring inside and stored as potential energy. So many toys you have used in your childhood days. So those were of key types. So used to insert a key and rotate it clockwise. So when you rotate it clockwise, what happens is there is a spring inside, the spring gets tightened. So when you release it on the floor, the spring comes to its or regains its original position, and because of that, the toy car moves. So the wound spring is an example of potential energy. Here also you can notice the word due to its position. As long as the spring is in the winding position, it has potential energy. Once when it is released, it moves away. No more potential energy is there. Next, if we lift an object to a height and release it, it falls down. When the object is lifted, energy is transferred to it and stored as potential energy. For example, if you lift a ball from the ground. So when you lift a ball from the ground, you do some work, right? And as long as the ball is in your hands, it is having potential energy. Once when you release the force on your fingers, the ball begins to fall down. Therefore, the ball on your hand possesses potential energy due to its position. So now you may be able to understand the definition correctly. The potential energy of an object is the energy possessed by the object due to its position or shape. So the examples which we had seen here is stretched rubber band, a wound spring, and a ball lifted and about to drop. The ball is about to drop has potential energy. Now, this slide also gives you information about the potential energy. Energy that an object has due to its shape or position is called potential energy. The potential energy that an object has is due to its height above the Earth's surface. Now here you can see three examples given as pictures. In the first picture, a man is about to shoot an arrow with a bow. So this arrow will be in his hand as long as he holds it. So the arrow in his hand is possessing the potential energy because the bow is stretched. Then the next diagram is a ball on a cliff, on the top of a cliff. So it possesses potential energy because it is not moving. Perhaps if a strong wind blows, it displaces its position. So where the potential energy is transferred into kinetic energy, this concept we will see lastly, transformation of energy. And the last slide, you can see the kids enjoying the game which is called as giant wheel. So a giant wheel goes up and down, and so these children are there in the top and they are about to descend. So their position is an example of potential energy. So let us take up some examples. You see some examples are also given for potential energy. Energy stored by water in overhead tank is due to its position. So this is also an example of potential energy. A stone raised to a height possesses potential energy due to its position. This I have explained to you earlier. An arrow released by stretching of a bow due to its change in shape. So it is an example of potential energy. A stretched rubber band contains potential energy due to its change in size and change in shape. A raised hammer or a hammer raised to a height has potential energy because once when it is released, it will about to fall, which does the work. So in short, potential energy is defined as the energy possessed by an object due to virtue of its position. Now we will see about the gravitational potential energy. Gravitational potential energy. Gravitational potential energy is the energy stored in an object due to its position above the Earth's surface. So the examples which we had already discussed, the water stored in the overhead tank has potential energy due to its position. A raised hammer has gravitational potential energy due to its position. A ball on your hands which you are about to drop, it has potential energy due to its position. So the potential energy stored by these objects due to its position, it is known as gravitational potential energy. So the formula for this is EP, that is gravitational potential energy, is equal to mgh, where m stands for its mass, which should be in kilograms, g the gravitational field strength, which will be 9.8 meter per second square, and h is the height, and EP is the gravitational potential energy. So gravitation G is expressed here as Newton per kg, but we usually express it as meter per second square, right? So gravitational potential energy is the energy possessed by an object due to its position, and it is calculated by the formula mgh. This slide gives you the more information about gravitational potential energy and its calculation. When an object is raised to a height, its energy increases because the work is done on its against gravity. The energy present in such an object is called gravitational potential energy. If an object of mass m is raised to a height h from the ground, the force required to raise the object is equal to the weight of the object, which is nothing but mg. So force is equal to mg. So work done has a formula, force into displacement. Force is mg and the height we represent it by the letter h. So when we multiply, we get mgh. So work done in raising the ball or an object to a height h is given by the formula mgh. So the work done here is nothing but the potential energy because of the position. So the potential energy gained by the object is nothing but the work done in lifting it up. Therefore, it is also having a same equation mgh. Now let us look into the problem. Find the energy possessed by an object of mass 10 kilogram when it is at a height of 6 meters above the ground, given g is equal to 9.8 meter per second. So mass of the object is given as 10 kilogram. Displacement, that is the height, is given as 6 meters. So acceleration due to gravity g is given as 9.8 meter per second. And we are asked to find out the energy possessed by the object. So since the energy is at a height, it is having potential energy. So the formula for potential energy is mgh. So multiply the mass with g value and the height. Here it comes around 588 joules. Children, this slide gives you the introduction of kinetic energy. Before that, let us revise what energy is. The energy of an object is its capacity for doing work. The unit of energy is same as that of work, that is joule. 1 joule is the energy required to do 1 joule of work. 1000 joules makes 1 kilojoule. There are different forms of energy. They are heat energy, light energy, electrical energy, chemical energy, mechanical energy, which is nothing but a combination of potential and kinetic energy, etc. Now we have already seen about potential energy. Let us now pass on to kinetic energy. The kinetic energy of an object is the energy possessed by the object due to its motion. The word motion here is very important. When the object is in motion or when the object is moving, we call the energy possessed by it as kinetic energy. Previously in potential energy we have seen due to its position. Now here it is due to its motion. When the body is moving, then the energy possessed by that body is known as kinetic energy. All moving objects possess kinetic energy. A falling coconut, a speeding car, a flying aircraft, flowing water, blowing wind, a running athlete, they all possess kinetic energy. The kinetic energy of an object depends upon its speed. An object moving faster has more kinetic energy than the object moving slower. So we will learn more in detail about this kinetic energy in the upcoming slides. Children, look at this slide which reveals you about the examples of kinetic energy. Now when you look at the ball, first ball, the ball is stationary. Since the ball is stationary, which is not moving, it has no kinetic energy. But you can see the ball which is on the right, the ball is moving. So the moving ball possesses kinetic energy. Now in the second figure, the gun is loaded with the bullets. The bullets inside the gun, it is not having motion. So it has no kinetic energy. Now on the figure on the right, the bullet escapes out of the barrel and goes into the air at a very greater speed. Now this bullet possesses kinetic energy. So we can conclude any body which moves possesses kinetic energy. This slide gives more examples which will develop your understanding more. Kinetic energy, the energy of motion that is released from a stored energy. First example, an arrow released from the bow flying through the air. So as long as the arrow was in the hands of the shooter, it was possessing potential energy. Once he releases the force on his fingers, this arrow is released and flying through air with a speed. So this arrow which moves has kinetic energy. An object rolling down the hill. So previously we had seen a ball kept on the hilltop that was possessing potential energy because it was not moving. Now the cyclist is moving down the slope and so he has a speed and hence he has kinetic energy. Here you can see the sprinters, they are moving on the ground. So they possess potential energy. Then a car moving, a moving car, since it has speed, it has kinetic energy. So what similarities do you notice all about these examples? All the examples reveals the bodies are under motion. So any body which is under force and they are moving with a speed, they possess kinetic energy. Now let us sum up the kinetic energy of the one which we had seen now. The energy which is possessed by an object due to its motion is called kinetic energy. Its SI unit is joule. Kinetic energy of a body moving with certain velocity is equal to the work done on it to make it acquire that velocity. Kinetic energy of an object increases with its speed. Due to kinetic energy, a bullet fired from the gun can pierce a target. A moving hammer drives a nail into the wood. Due to its motion, it has kinetic energy or ability to do work. A running horse has kinetic energy. A running horse has kinetic energy. The kinetic energy possessed by an object of mass m moving with a uniform velocity v is given by the formula kinetic energy is equal to half mv square. This equation is a very important equation which helps us to calculate the amount of kinetic energy, that is half mv square, where m stands for its mass and v stands for its final velocity. Children, this slide is a very important slide which gives you the derivation of the kinetic energy. We have seen in the previous slide, kinetic energy is calculated by the formula half mv square. How did we get this equation half mv square? So we have to derive this equation. It's a very important question as far as CBSE board is concerned. Calculation of kinetic energy. The kinetic energy of an object is measured by the amount of work it can do before coming to rest. Consider an object of mass m moving with a uniform velocity u. A force F is applied on it which displaces it through a distance s and it attains a velocity v. Now again let us see to the one correlating with the diagram. So here we have a body of mass m and a force F is applied onto this body. So when it is about to move, it has an initial velocity u. So because of the force, the object moves to a distance and the distance covered by the body is s. Now it goes to a new position and the velocity changes as it moves. Therefore, v is the final velocity. The work done here is nothing but force into displacement, which is the formula which we have already seen. Work done has a formula force multiplied by displacement. Now let us take up the Newton's second equation. V square minus u square is equal to 2as. From this we get a formula for s. So when you transpose 2a to the other side, s becomes s equal to v square minus u square divided by 2a, where here a is the uniform acceleration, u is the initial velocity and v is the final velocity, as you all know. Also we know that F is equal to ma, where F is force, m is the mass, a is the acceleration. Substituting the value of F and S in equation 1. So in equation 1, W is equal to Fs. Let us substitute the value of F and S in that one. Therefore, W is equal to F is equal to ma, and a acceleration, that will be is equal to v square minus u square divided by 2a. So that is the displacement. So W is equal to F into Z. We have substituted the value for F and we have substituted the value for S, the displacement. Now here you simplify this, it becomes half m into v square minus u square, right? So this is known as work energy theorem. So this is known as work energy. Work is converted into energy. That's why it is called as work energy theorem. That is, the total work is equal to the change in the kinetic energy. If the initial velocity is u, then W becomes half mv square, which is the equation for the kinetic energy. So children, this is a very important derivation. So we will start with the an object which has an initial velocity u is kept by affected by a force F, which makes it to displace through a distance S, and it moves with an final velocity v. Work done has the formula force into distance moved. Force has a formula F is equal to ma, and S has a formula S is equal to v square minus u square by 2a. With this we get it from the second equation of motion. So substitute both these values and simplify, and finally substitute the value of u is equal to 0. We get very easily that it is the kinetic energy is got by the equation half mv square. Now let us apply the formula of kinetic energy in solving a numeral. The kinetic energy possessed by an object of mass m and moving with a velocity v is given by Ek, that is kinetic energy, is equal to half mv square. Example, an object of mass 15 kilogram is moving with a uniform velocity of 4 meter per second square, 4 meter per second. What is the kinetic energy possessed by the object? Mass is given as 15 kilogram. Velocity is given as 4 meter per second. So substitute in the formula half mv square, half into 15 into 4 into 4, it gives 120. Since the SI unit of energy is joule, it is 120 joules. So the kinetic energy possessed by the object is 120 joules. Children, we have come to the end of today's learning section. We have seen about the energy today. So the definition of energy, the capacity to do work. The SI unit of energy is joule. And among the various types of energy, we have taken up the mechanical energy, which is a combination of potential energy and kinetic energy. Potential energy is the energy possessed by an object by virtue of its position. Kinetic energy is defined as the energy possessed by an object by virtue of its motion. Potential energy is calculated by the formula mgh. Kinetic energy is calculated by the formula half mv square. Also we have seen some numerals, and so that is the end of today's learning section. So keep revising, and I will give you some questions or the numericals to solve separately. So do that also. So we will meet next time, next week, children. Until then, bye from you.